everyone, we are Cao Jiali, Huang Haixin, Cao Kaiting, and Yang Mingxuan. Our topic is movie schedule optimization using sentimental analysis of movie reviews. Here is the agenda of our presentation. So let's talk about our motivation first. The majority of cinema income is from screening new release films. A hit film results in high ticket income. Therefore, film arrangement is an essential task for cinemas. Traditionally, cinemas would predict a high box office for a movie with famous producers, popular cast, and high budget. This is also how audiences made their decision in the past. However, with the spread of SNS and online critics' commentaries, people tend to search for comments on the internet before buying a ticket. As a result, people's comments become more and more important to affect the revenue of a movie. So, our objective is to analyze online comments to improve cinema's film arrangement. Firstly, we would like to understand whether ranking on movie rating websites will indeed affect potential audiences' willingness to watch the movie. If a movie has a high rank, it will attract more audiences to go to the theaters. However, for newly released movies, the websites should wait for days to conclude a rating, and cinemas apparently could not wait. They need to conclude how the first batch of audiences react on SNS and use the information to arrange their screenings. So, the next step is to predict the rating. We decided to formulate a model to analyze audiences' sentiment by their text comments on the internet. In this way, cinemas can easily gain a quick conclusion from people's comments and make decisions. To achieve our goal, we firstly applied linear regression to gain the effects of internet rating on movie revenue. Then we use text blob to explore the polarity and subjectivity of movie review comments. After that, we evaluate the plan accuracy and confusion matrix of 4 models: logistic regression, the SVM, naive Bayes, and K-nearest neighbors classifier. And finally, we chose naive Bayes as our final model. Let's firstly talk about the linear regression. We used about 2,500 rows of movie data to form the regression, with revenue as the dependent variable and vote average as the major independent variable. The coefficient of vote average is about 0.5 and p-value is 0, which means vote average has a significant positive correlation with movies' revenue. The result matches our hypothesis and we can move to the next step.
Moving on to the next step, we conducted sentimental analysis on movie review contents and explored our datasets and come up with some preliminary results. We used the Rotten Tomatoes review dataset from Kaggle and choose 10 years data from 2011 to 2020, because we think that the recent 10 years data collected online are more reliable. The dataset contains about 60,000 rows and 8 columns. We extracted 2 rows from data to show you what the dataset looks like. For data cleaning and pre-processing, we cleaned up rows with null values and encoded categorical data into numeric data. We encoded review rank to review score. The review score ranges from 1 to 12 and corresponds to F to A. For example, A corresponds to 12, B plus corresponds to 11, and so on. We also encoded review type to sentiment. There are 2 review types, fresh and rotten. Fresh means that the movie was given a review score greater than or equal to 9, whereas rotten means that the movie was given a lower score worse than 9. We encode fresh as 1 and rotten as 0, and place the dummy variables into sentiment column. Then we use an existing package called TextSwap to analyze the review content's polarity and subjectivity. What does the polarity and subjectivity score mean? The polarity score ranges from -1 to +1, with negative values meaning that the text is negative and positive values meaning that the text is positive. The subjectivity score ranges from 0 to 1, with 0 meaning that the text is very objective and 1 meaning that the text is very subjective. The scatter plot illustrates the polarity score distribution within each review score. As you can see, there are more data points that have a positive polarity score in higher review scores, and there are less data points that have a positive polarity score in the lower review scores. For example, at review score 12, we see there are comparatively less data points that have a negative polarity score. Furthermore, we computed the average polarity score in each review score range. Interestingly, the higher the review score, the higher the polarity score. We can therefore conclude that the polarity score and the review score have a positive correlation. We also wanted to know if the polarity score has a significant effect on the review score. So we ran an OLS regression model, and the results show that the polarity score has a positive coefficient and a 0 p-value, meaning that the polarity score has a significant effect on the review score, and the two are positively correlated. We also plot all the data points to see the relationship between the polarity score and the subjectivity score. In this preliminary result, we can see that the more polar comments tend to be more subjective, and the result really makes sense for us. On the other hand, we wanted to see that for each movie, is there a correlation between the polarity score and the review score? So we calculated the average polarity score and the review score for each movie. To make it more robust, we also filter out the comments that are too subjective, which are the ones with a subjectivity score greater than 0.8, and the movie that only have one comment. Therefore, in the end, we have all the data points that have a subjectivity score that's less than or equal to 0.8, and we have 2 or more reviews contents for each movie. The results shows that the average polarity score and the average review score have a slightly positive correlation. Now that we have explored our dataset with sentimental analysis results, we move into the next step, which is predicting movie sentiments with review contents using classification models.
We use for a classification model with the same dataset, Rotten Tomato review to train review content to predict movie sentiment. But how can we improve review content as independent variables? We use 2 algorithms, count factorism and TF-IE factorism. The count factorism considers the frequency of words in a sentence, while TF-IE factorism considers both the frequency a word appears in a sentence and the number of sentences the word appears in. We run 4 models, include logistic regression, SVM, naive Bayes, and KNN. Let us view the result in the next slide. This is the accuracy of different models we got. From this table, we can find out that compared to accuracy rate calculated from the TF-IE factorism, the accuracy rate calculated from the count factorism generally have a better performance. Furthermore, we can find out that no matter training or test accuracy rate, naive Bayes has comparatively higher accuracy rate, so we choose it as our final model. In the test dataset, There are 70,498 data points, with 11,302 positive sentiment and 6,198 true negative sentiments. The data is unbalanced, with about 64.58 positive sentiment. Therefore, we further look at the confusion metric on the model. They are internally improved with count factoristic factors. In SBN, KNN, and logistic model, almost all the sentiments are predicted as positive, which is sentiment equal to 1, and very few sentiments are predicted as negative. Only the naive Bayes model have slightly more accuracy prediction with 60,356 positive and 1,142 negative sentiment prediction. Furthermore, we visualize the most frequent positive and negative review word. We use the word crowd package and found that funny times surprising are most used by reviewers in the positive review context, while thriller, far-fetched are most used in the negative review context.
In terms of business application, in a real-life setting, it is crucial for film investors and stakeholders to understand the market demand for the film they invested in order to maximize profit. And a common way to do that is through premieres and test screenings. We believe that stakeholders and investors could utilize the viewers' comments from the premieres and test runs and perform sentiment analysis on them to extract the initial responses. We could combine viewers' demographics with their common sentiment analysis and figure out which group responded the best to the film and which ones detested it or find it somewhat off-putting. This way, investors of the film could choose to make smarter decisions, such as screening it more in specific states where the demographics are most likely warm to the content, or air it during times where demographics would visit the cinemas the most. And for the groups that didn't like the film that much, the editors could even conduct some further editing and blurring to make sure that the movie are welcome to the wanted target audience and therefore generate the most revenue out of each film. In conclusion, we have determined that the multinomial naive Bayes model has the most accurate predictions in comparison with the other models in the setting of predicting sentiments with movie comments. However, there exists a few areas that could be navigated and improved further upon. To start off, we ruled out some comments that we consider as too subjective and too polarized. But there are films that have such a strong, unique characteristic that only appeal to a certain crowd. So some comments might love it and some comments might hate it, but it both need to be included to arrive at an accurate and relevant prediction. Secondly, this accuracy issue might also occur as we tokenized words. We could easily break down a sentence into words that didn't convey its original implication. For example, a comment says, "A huge mistake if you don't watch it over 100 times broken down into individual words could give the wrong idea." This could be further improved if we can incorporate more phrases and short sentences in the model to start off with, and therefore interpreting a wider range of sentiments. Another important issue to consider is that during the initial analysis of our data, we recognize that sentiments are in values of only ones and zeros. That is, identifying emotions that are purely positive and purely negative. However, words and emotions have different levels of positivity and negativity. Thrilling could be a comment that sends off the wrong message. To further improve the accuracy rate of a classification model, we can add a more refined score to reflect comments and emotions, and eventually produce a movie classification that is more than just good and bad. And with that, we finish our presentation on our movie screening optimization with sentiment analysis. Thank you so much for your time and support.